Imagine working comfortably in your everyday development environment. You have just wrapped up some unit tests, and you're ready to write the next set of test cases in your QA workflow. You now have to step into another world, the world of SIL and HIL. Suddenly, everything feels shockingly complex and incredibly all over the place. Instead of just directly coding and writing your tests, you have to learn hundreds of new tools from different vendors having their own logic, their own formats, and even their own API personalities. That's just to run the tests locally, just to get started. Now imagine trying to integrate all of these complex tools into your existing CI/CD workflows. Sounds like a great day, right? Hello, my name is Yusuf, and today we will take you through a journey from today's pains to tomorrow's gains. I wanted to show you this with a concrete example. Imagine you're writing some tests where you need to modify some variables in your simulation environment. If you're using dSPACE simulators, whether it's hardware in the loop or software in the loop, you can use the standardized ASM/XIL API interface. And if you're lucky, maybe the third-party simulator that you have standing supports it as well. Let's say now you connect your ECU or virtual ECU, and you need to do some calibration. You need to understand the ECU port in this case. It's also part of the ASM/XIL API. Maybe then you need to add some short circuit scenario, which means you need to also understand the EES port, also part of the ASM/XIL API. Meanwhile, you still need to access some parts of the infrastructure that are only available through tools like control disk, for example, XCP services or for calibration or CAN monitoring. And to make this even more interesting, you might want to run all of this while the control unit is driving through a scenario with specific parameters and realistic sensor simulation. Then you need to use two other sets of tools or software. And this, by the way, is the good case scenario. This is where your third-party simulator supports the standard interfaces. If not, then I'm sure this vendor probably has their own idea of how their simulators should be controlled, and they have their own personality. Lots of time wasted that should be rather invested in writing the tests itself. This is a type of pain that I personally don't want to be dealing with. I'm sure you are as well. But wait, don't run away. We have a solution. The solution is a Test Automation SDK, short for Software Development Kit. It provides you with a unified interface to address the different use cases and testing needs. This serves as an abstraction layer that hides complexity, but by design, and this is something we really took care of, that it's open and to modifications and extending it with third-party interfaces in a way that these integrations are seamlessly in the style of the Test Automation SDK as to not again fall into the trap of having inhomogeneous integrations in your test development tool. Now, this is where it gets interesting. Everything I showed before covers just one part of why such a solution is important: abstracting complexity and simplifying your daily workflow. Once all that complexity is hidden away, you're left with regular native Python test cases that run anywhere, Windows, Linux, or even inside Docker containers. And instead of reinventing the wheel, we chose to build on what already works. For execution, we use Pytest, which is already widely used in the software world. For reporting, we didn't create a new format. We just relied on existing powerful tools like Allure Report, which already provide everything you might expect from a modern reporting system. We integrate these tools out of convenience so you can start writing tests directly, but if you prefer another framework, Robot Framework for example, you can plug it in easily. The SDK stays independent and acts simply as a foundation underneath. Now let's talk CI/CD. With SDV and Chef left becoming more important, CI/CD is no longer optional. Out of the box, your tests fit naturally into whatever infrastructure you are already using in the regular software development. And yes, I'm aware that during the last minutes I committed a major sin, giving a talk in 2026 without mentioning AI. Don't worry, Python is naturally the best language to use when thinking about AI-assisted test development. The concept of abstraction is not only good for humans, but it's also for robots, as AI test generation quality improves drastically based on how much guidance and clearance the AI has. With this approach, you become genuinely future-proof. You don't have to wait for the latest AI trend to be retrofitted into your special test authoring and execution tool. Just use VS Code, and you don't need to wait for some special test management tool to support the newest CI/CD feature. Just use Git. You are now open to an entire world of solutions supported by a massive open source community, and not a limited subset of whatever could be retrofitted. Here is how your day would look like when integrating the Test Automation SDK in your workflow. You'll be writing your tests in your familiar coding environment, for example, like VS Code, whether you're writing it on your own or with AI-aided test case development. After writing your test cases, you can then commit the newest changes to the control unit, the newest changes to your test cases, and to the requirements. You can commit this to Git. After committing this, you will trigger two pipelines, one to test the newest changes in a SIL environment, and one to test the newest changes on a HIL environment. And because you're using the Test Automation SDK, you don't have to rewrite the tests or worry about the difference in configurations between the two environments. You just use the same test cases and run them in both environments in both pipelines. After this test execution is over, you can then get the results and start the analysis process. Looks familiar, right? As you can see, the demo screen is split into 3 parts. On the left side, we have Visual Studio Code, where the tests are. On the top right side, I opened an Allure report, so you can see it live while we're executing. And then on the bottom right side, I have the platforms and devices that I'm currently connected to for the execution. In the demo today, we will be testing the turn lamp signal of a car. As you can see, the test starts quite simple. We have the first initialization phase, where we set the battery voltage of the car to a certain value. Here, governed by the parameterized function of the Pytest, where we can go through multiple values with the same logic of the test case. We then make sure that the lever is turned off at the beginning of the test. We then start a capturing phase, where we capture all the different signals that are of interest. While the capture is running, we set the turn signal lever to trigger that the right turn signal of the car should be on. We then wait for 3 seconds capturing the behavior of the signal, and then we turn the signal lever back to off. We then have a function where we do the evaluation of the captured signals. As you can see, the test looks quite simple, abstracting whatever tool or way of accessing the variables that's in the background. By the way, I forgot to add a signal. With the IntelliSense provided, you can directly see what kind of signals are available in your current environment. So let's choose the battery voltage. You might be asking, how would the test case know via which interface would it be able to access or manipulate the value of the signal? Well, it's all about this configuration file. Next to the test case, you give it a parameter or you give it an input, which is this configuration file. This configuration file identifies which interfaces are available for the test case to be able to manipulate the signals from. For example, in this one, we defined for our scenario today a simple MR port, XIL-ASM XIL-API MR port. Via this configuration file, the Test Automation SDK understands that the battery voltage is a variable that can be manipulated through this interface. I wanted to bring another example today of how it would look like if you maybe have 2 different interfaces. So you can say some variables or some variables are accessible via the XIL-API port, some others are accessible via the control disk. This configuration is in the background. For the test case itself, it doesn't matter. Whatever tool is in the background, whatever interface in the background, it doesn't matter. The test case stays the same. Whether this is VEOS or SCALEXIO or HIL or SIL, this has no effect whatsoever on the test case. Now, let's run the tests. First, I will run the tests on my local machine using VEOS. So all we need to do is to go to our test execution pane, and then we just run the test case. Let's start with 10 volts. Now the test is running. As the configuration file identified that we're in a VEOS environment, it automatically started up the application under VEOS and ran the test case. As we can see, the test case has passed. And now we run the same test case on the SCALEXIO. All I need to do is to simply switch the configuration file. When I run the test case, the Test Automation SDK will recognize the change in the configuration, and it will automatically recognize the SCALEXIO, load the application, start the test case, and give us the results. As you can see, the test case now is ran with passed on both VEOS and SCALEXIO. You can then see the details here about the test case and, of course, the plots. As you have noticed, the test case is only testing the right side of the turn lamp signal. I would say we can extend it to test both sides. It's the same logic. But I don't want to do it myself. I will ask my copilot. I'll ask the copilot I would like to extend the test case with parameterization to test both left and right turn signals. And we wait. As you can see, the copilot is having a really easy time understanding the code structure, understanding the pure Python test case that's in front of it. It doesn't need to understand complexity of the tools, of the different interfaces. All it needs to do is to modify some simple Python code. A task that is nowadays quite easy for an LLM. As you can see, Copilot finished modifying the test case. You can review the modifications that have been done, and then you can decide whether you can keep them or not. We decide to keep the modifications that the Copilot has done. And as you can see, right now we have two different variants of the test case. We have the direction, whether it's right or left, and the battery voltage. And now we can run all of the test cases. And here, as you can see, the results of the full execution for the different battery voltage variants and for the different sides of the turn lamp. And here comes the closing slide, where I show you the key benefits of the Test Automation SDK, if you haven't seen it yet. The seamless transition when testing from SIL to HIL. You don't need to change your test code. The Test TA SDK is an enabler. It enables you to leverage the most recent advancements in AI and modern testing workflows. It integrates out of the box with your existing CI/CD infrastructure. And of course, it will be ISO 26262 certified for testing in critical areas, for example, like in automotive. If you're interested in the Test Automation SDK, contact us at dSPACE.com.
dSPACE, your partner in simulation and validation.